Second part of the exam review. Numbers 11 and 12 are about adding or subtracting polynomials. So when we add, we don't really have to worry about the parentheses. What you see is what you get. When we're subtracting polynomials, we're subtracting the entire parentheses. So I like to think of it like distributing that negative sign. All right, so let's handle number 11 first. Okay, just noticed I wrote the problem down wrong. Should be 5x squared plus 3. All right. So what I'm looking for is like terms. 5x squared and x squared are like terms because they have the same variable part. 5x squared plus x squared is 6x squared. And then plus 3 minus 7, a positive 3 and a negative 7, make a negative 4. And this is in standard form because it's in exponent order from highest to lowest. X squared down to no x's at all. If I did negative 4 plus 6x squared, that is not standard form. Because I'm supposed to go left to right, highest to lowest. So over here, my first step has to be distributing that negative. So I'm going to rewrite my whole problem with that result. So minus 9 plus 2x instead of minus 2x, and minus x to the fourth instead of plus. All right. Now I can go back to finding like terms. I've got an x to the fourth and an x to the fourth. So plus 2 and minus x to the fourth. Positive 2 and negative 1 make a positive 1. That's just 1x to the fourth. We don't really need the 1 there because it's not doing anything. And let's find our next biggest x. All right, I've got an x squared. It's the only one, so it doesn't combine with anything. I just rewrite it down. I like to sometimes do something different with all my different like terms. So I'll box that one. And then my normal x's, I have a plus 2x. I'll circle that. It's the only x term. So again, it just gets rewritten. And then I'll do a squiggle around my normal numbers. I've got a plus 2 and a minus 9. So that comes out to a minus 7. All right. And that's in standard form because 4, 2, 1, 0 for my x's, highest to lowest with the exponents. Number 13 is really just a vocab problem. Write a third degree trinomial. Third degree means biggest exponent is 3. Trinomial means 3 terms. Leading coefficient means 4 in front of biggest term. All right. So to write this, I'm going to put a 4x cubed, and that takes care of the leading coefficient and the third degree part. Now I just need to make sure I write 2 more terms to get 3 terms, so plus something, and I have to make sure I don't go over 3 on the exponent. So I could do like 2x squared plus 1. So check all my boxes here. 3 terms. The biggest exponent is a 3, and the leading coefficient is a 4. The 4 is in front of that x cubed term. So really just a vocab problem. You either know it or you don't. There's no calculating to do. You just come up with something. You just need to know what the words mean. The next few problems are about finding the product, which means we're multiplying polynomials here. So the first thing to look at is c plus 2 squared, which means c plus 2, c plus 2. We had a bad habit, some of us, of saying c squared plus 2 squared. No, that is not what that means. You can't apply the exponent like that when things are added inside. Exponents mean multiply by itself, so we're going to multiply the whole parentheses by the whole parentheses. And this is what we get out of it. So now we're going to use that box method, Punnett square, to organize our multiplication. because each term needs to get multiplied by each other term. C times C is C squared. 2 times C is 2C. C times 2 is 2C. And 2 times 2 is 4. Now we look for any like terms. We have 2C terms. So does that up to 4C? So our final answer is C squared plus 4C plus 4. All right. So we can't just distribute the 2 like an exponent property because it doesn't fit the rules we need to follow where everything inside is multiplying. We have to do it like this. Number 15 is 3a squared plus 2a minus 2 and a plus 1. And again, we're going to use the Punnett square, 3a squared, 2a minus 2. That was a really bad 2 up there. And a plus 1. All right. Let's start multiplying. 3a squared times a is 3a cubed. Now there's 3a's multiplied together. 3a squared times 1 is just 3a squared. Anything times 1 is just itself. 2a times a is 2a squared. A times negative 2 is negative 2a. 1 times 2a is 2a. And 1 times negative 2 is negative 2. So I'll circle like terms again. It looks like 2a and negative 2a are going to be able to cancel out. Those would make 0. But then I have 5a squared here. So I'm going to have 3a cubed plus 5a squared minus 2. Again, that a term got canceled out, so it doesn't even need to show up. We could write plus 0a, but it doesn't really do anything. One more Punnett square problem. Number 16, 4x plus 3 and 4x minus 3. Four x times 4x. 4 times 4 is 16. X times x is x squared. 4x times 3, that's 12x. 4x times a negative 3, that's a negative 12x. Negative 3 times 3 is negative 9. These match, but they're opposites, so they're going to cancel each other out. They're like terms, but they add up to 0. So my answer is 16x squared minus 9. Punnett square problems are really repetitive. It doesn't matter how big they are. You just make that box and make sure you multiply everything in rows and columns like a Punnett square. For this factoring section, I would urge you to actually write down some examples for yourself, because this is one of our longer, more complicated processes. So giving yourself a couple of factoring examples might help you along a lot on the test. So for factoring completely, we add kind of like a branching decision-making process. We start by looking for anything I can factor out like normal, like divide out of all the terms, but this m doesn't have any numbers in front of it, and this 6 doesn't have an m with it. I actually can't do any normal factoring with this one. So I'm going to start with factor by grouping because I have 4 terms. So I'm going to put my first 2 and last 2 terms in parentheses. Sorry, I want to take that plus sign too, because if it's a minus sign, it makes a difference. And then I factor out what I can of each of these things. This is why it's called grouping, or grouping things. So I can't factor any numbers out of the first one, but this has 3 m's, this has 2. They can both give up 2 m's. So I'm going to factor out m squared. Over here, 3 and 6 are both divisible by 3. I can't take out any m's, though, because the 6 doesn't have any m's to give up. So when I rewrite this, my first term or my first parentheses, factored out an m squared. M cubed divided by m squared is just 1m left. And then minus 2, both m's are gone, so m minus 2 is it. Plus, I factored out a 3 from this one. 3m divided by 3 is just m. Minus 6 divided by 3 is 2. So our goal here is that these parentheses match up. They're both m minus 2. That's a sign that we did our job right. So now, still factoring by grouping, once those parentheses match, I'm supposed to factor that out. So I get m minus 2. And then the leftover stuff was the m squared in front and the 3 in front. So this process is called factoring by grouping. That's all we have to do for this one, because there's nothing else to factor here. Sometimes we'd be able to factor the m squared term, but not this time, because I'm not going to be able to find something that works. If it was a difference of squares, like m squared minus 4, then I could keep going, but not this time. Next one I got a factor, number 18. Again, some of these are going to look really different. That's why I'm saying I'm going to encourage you to write down a couple of examples so you hit all your marks. 3x squared minus 48. Well, this one does have something I can factor out from the start. 3 and 48 are both divisible by 3, so that's a good choice right now. So I'm going to have 3x squared minus 16. And now I focus on factoring the parentheses, x squared minus 16. This is a difference of squares. So you can just have this memorized, or we can go over here and do the work and then rewrite it as x squared plus 0x minus 16 so we know what our b value is. And then we look for factors of negative 16 that add up to 0, and it comes out to 4 and negative 4. So then I'm going to make my box. I've got x squared here, negative 16 here, and then these two fill in these slots, 4x and negative 4x. And that makes sense because those would add up to 0x, just like in the equation. So then I'd play my little number game. These both have to be x. Well, then x times negative 4 is my only way to get negative 4x, and x times 4 is my only way to get 4x. And then I get these two parentheses. So we can show our work, but difference of squares is supposed to be a little faster than that. This is like the reverse Punnett square method. There was another way where you did it like factoring by grouping, but there's a lot of strategies here. Again, it might benefit you to go back to Chapter 7 notes and find a couple of really good examples and get those on your note card, just so that you know exactly what you're doing. So we have one more that's like a more full factoring problem that doesn't really have shortcuts. So number 19 is going to be 15b squared minus 4b minus 4. There's nothing to factor out from the start, so I just have to jump straight into my factoring process. I do a times c, which is 15 times negative 4, and get negative 60. Not 16, 60. Said it out loud to myself and then wrote down the wrong thing. And my goal is to find something that adds up to negative 4. So my bigger number has to be the negatives. So my options are 1 and negative 60, 2 and negative 30, 3 and negative 20, 4 and negative 15, 5 and negative 12, 6 and negative 10. So those are all my options. 6 and negative 10 is the one that ends up adding correctly. 6 plus negative 10 is negative 4. That's my goal. So let's draw out the box. 15b squared has to go here. Negative 4 has to go here. And then 6b and negative 10b fill in the other two spots, wherever they go. So I like to start with the row that's negative, because then I know I'm going to have to factor out a negative. And what's the biggest thing that divides these two? Well, they're both divisible by -2. So that's where I start, is I look for the greatest common factor, and I like to pick the negatives first because I know that's where I'm going to get my negative number from. So then what times -2 is -4? -2 times +2. And then 2 times something gets me 6b. That has to be 3b. 3b times something gets me 15b squared. This has to be 5b. Now let's check and make sure everything worked out. 3b times 5b is 15b squared. That's good. -2 times 5b is -10b. That's good. -2 times 5. 3b times 2 is 6b. And then the first one we checked, easy one, 2 times -2 is -4. So these have to be my factors. 5b plus 2 and 3b minus 2. Again, there's a way to do that by factoring by grouping. I'm pretty sure I did that on some of my answer keys back in chapter 7, so if you want to take a look at other ways to do it, go take a look at some of those notes.